Okay, so the plan is to take this statistics quiz in linear regression now, and then we do some more exercises, and then later today we can take the second quiz I made. So should we wait a little? Do you think is there a delay on the trains or something? No. Okay. Yeah. Okay, so you log in here with a PIN code as usual. It's only 10 questions, but they're a bit difficult maybe. It's all about linear regression. So all the questions, there's an output from Freestat, and you have to answer regarding the output whether some questions are true or false. Why are you so far away from me today? Ah.
Og der så helt op og bare tænkte, at du måske kom til at sidde lidt for selv. Ikke at det vil gøre noget skidt.
Oh, very nice. If you hurry up, you just get in on the quiz.
Let me tell you don't recognize that game. Det er der, du skal skrive
So who's not in yet? Are everyone in? Can I start or? Ah, very nice. So why did you answer there was a linear relationship? Or maybe I can rephrase. How should the scatter plot look in order for you to say there was no linear relationship? So this is, you all said yes, and was this because there was no points here and here, or?
If it was placed far to the right or far to the left, there was no linear.
Yeah, but you were right, it does appear as if there's a linear relationship. Okay, we go on. Fast luftig. Yeah. But be careful, you have to read it. You have long time, so you have to move closer then. You have more than a minute still. You have to calculate something. Not guess, but calculate. Oh. So a lot of you didn't calculate anything, or you didn't know what to calculate, or? Okay, then we'll just have a look at the output. So this was the output, right? How can I calculate the correlation based on this output? The correlation coefficient is not in this output, but the R square value, do you remember from last time, that the R square value is the correlation coefficient squared. So if you take the square root of this number, you get the correlation coefficient. So please try to do that and see if you get the right answer. If I didn't make a mistake, right? So you should get 0.82, hopefully. You know how to find the square root, right? You take this number and then add 0.5. I forgot my mark. Do you get the number?
Yeah.
Perfect. Can you all get it? So they are quite heavily correlated, right? Can we say anything in regards to whether the correlation coefficient is positive or negative? Do we know anything about that based on this output? R square always have to be positive, right? So you will always get a positive number when you calculate the correlation coefficient. If you have to find out whether this should be negative or positive, you can look at this parameter estimate for size in square meters. If this is positive, then there's a positive correlation. If it's negative, then there's a negative correlation. I don't want to say too much because there's more questions, right? But did you all understand how we calculated the correlation coefficient? Yes. Perfect. So, what is the significance level if it's not stable? Yeah. Yeah. So it's 5%, right? And where do you find the p-value for the intercept? when we have a look at the output, where do we find the p-value? Yeah?
Bottom to the right.
Yes? Very nice. Right here. So this number is above 0.05, right? And the question was below. It's at below here, right? So this was false. Do you remember what we are testing? Maybe I have to run down and find the marker. I'll be back in a moment. Three markers now. So, do you remember what the null hypothesis is when we're testing the slope? It's the parameter is not nu, it's not p, it's some other Greek letter. Beta, yes. So it's beta, and we just write an I for intercept, right? Equal to 0, that's the null hypothesis. And the alternative hypothesis is beta I is not equal to 0. So we had a p-value above 5%, so we cannot reject the null hypothesis. So we cannot say that actually we cannot reject the hypothesis that the slope, the intercept is actually in 0. So if we look at the regression line, we cannot reject that the slope intercept in 0.0. Do you understand? Perfect. Okay, so we take the next one. Ah, very nice. You're good at this. Did you all understand why this is true, right? If we have a look at the output, we are testing a t-test. This is a t-test. It also says t here and t here, right? This is a t-test. And we're testing down here, we're testing if beta size is equal to 0. And the alternative hypothesis is that beta size is not equal to 0, right? In linear and multiple regression, we always is testing whether or not the slope is different from 0. So that is what we are testing down here, right? Ah, you're very good at this. This was a bit difficult trick question. So, how much of the variance in the rent price, the response variable, can be explained by the variance in size?
67.
Yeah, 67%, right? The R squared value. This is the explanatory power of the model, right? I'm very impressed. I thought you would find this quiz difficult. The next one is harder. Yeah, it is. You already said it. Who said 49? Yeah. So, can you explain this?
I just look at the estimate
Yes.
in size in square meter,
Yeah.
and it says 49, and that means that every time the vacation house is 1 square meter larger, then the price will increase by 49.
Yes.
7 kroner in average.
Perfect. Did you all understand that? Yeah. So it was not 379. That's just a standard error on the intercept.
Han kommer og stiller hovedet bagfra.
You're very good at this. Did you study at home? Or did you just pick it up here in class? So, what are we testing in the F test? This is the F test and this is the T test, right? What are we testing up here? We are testing if all betas are equal to 0. So up here, the test is beta. In our case, we only have one estimate, right? The one parameter. So this is size in square meters. So we are actually just testing if beta 1 is 0 and the alternative hypothesis is beta. Sorry, it's beta size. I just write SI for size. Is different from 0. And this is exactly the same that we are testing down here. So in simple linear regression, that is linear regression with only one explanatory variable, we will always perform the same test in the t-test regarding our parameter and in the f-test. So in multiple linear regression, these two tests are different because we have more than one explanatory variable in multiple linear regression, meaning that maybe we could have size and we could have distance to beach like last time or something else. So in multiple linear regression, we do more than one parameter test here. And of course, up here, we are testing if all the parameters simultaneously are equal to 0, right? This is beta n equal to 0, and down here the alternative hypothesis would then be not all betas 0. You remember from the mind map these two tests, right? There's only two tests in linear regression, the F test and then the T test. Not all betas equal to 0. So that's what we are testing in, and this will be the same if we are in simple linear regression, right? Ah, very nice. So, of course, the regression line, the slope is, if we have a simple linear regression, then the slope is actually just a parameter estimate from our output, right? So, this is the, I have to find the other. So these 49 there are the same as the 49 here, the slope, right? And the intercept, you can see if we continue this line, it should cross in 544. 544, that is the parameter estimate for the intercept, right? Okay, that was very good. I think you are quite good at this. Maybe we should just do the other test right away? Or would you rather have some exercises first?
The test.
The other exercise, the other test, that's for multiple linear regression. It's a bit harder.
I think we need some exercise.
Yes. Okay, we do that. Okay, so oh, maybe. Oh yeah, of course. I forgot one. Thanks. You have to calculate it. Oh, that's very nice. There's 3 persons who answered 544. Let's have a look at the output. the output says that the intercept is 544. How big is the house for the rental price according to our model to be 544 kroners per week? So you don't have to calculate anything. Zero, yeah, it has to be a house of 0 square meters. The rental price according to our model for a 0 square meters house would be 544 kroners per week, right? So it cannot be 544 or 545. So a 10 square meters house, how did you find out? Yeah?
Take the size in square meters, the estimate of 49.
Yeah.
And you multiply by 10.
Yeah.
And then you add the number you get there with
Yeah.
the intercept.
Yeah, so you say, actually you just say 545 plus 497, right? I think maybe I made a mistake when I added them together, but never mind. It was close. Yeah, okay, so this of course was, the right answer would then be 1045, right? Okay, so let's have a look here again. I think I'm very impressed because I thought this would be difficult for you. Jeppe, congratulations.
Var det anstrengt for
Det er
at
fordi,
ikke bruger jeres
Malte,
mail?
der er Malte i hjælpeklip, og så er det alle sammen så ikke navn.
Ej, hvor er det sødt.
Okay, so,
I hygger os herovre.
Det skal gøre med en af jeres navn.
Ja.
Ja.
Og det er sådan punktum og november.
so we go on with the exercises, right? Last time we did the first question 1, and I think we got started on question 2. I think we'll just start at the beginning of question 2. We have to look at the data set smokers. This is data from an American data set regarding a lot of smokers, and then we have a lot of information regarding their race and age and income, and what the cigarette price in the state is, and what level of education they have. It's in the data sets, so one second. Smoke or smokers? Can you find this smokers XLS? So it's rather large, the data set, so I hope your computer will cope. There's there's 807 observations regarding each parameter. Yeah, I'll wait. So when you have the data set, then you open Freestat. So in a moment when you're ready, or you can just start yourselves, just do a multiple linear regression. You of course have to have a response variable 6, meaning the number of cigarettes per day, and then all these explanatory variables in the first question, right? And then you can say something about this. And maybe if you do it now, then you can tell me how to do it also. I think actually it's easier when you take, you have to take the data from the data set and put them into Freestat, and you have to put always the response variable first. You remember that? The y variable should always be first when you put them into the MREG analysis, but it's easier instead of copying all together out from the total data set, take them one column at a time. So what I'm talking about is just because then you don't have to rearrange them afterwards. What I'm talking about is it's easier just to take 6 first and then put it here if they are not in the right order. That is, yeah, they are. Yeah. But if they weren't, then I think it's easier because last time I showed you can take parts of the data set and then you have to rearrange them anyway afterwards. So. Okay, should I leave this open here? But you also have it, right? It's exercise 4.
I have a question.
Yes?
What is the red and the green?
Yes. What are the red and the green halloisa? The red and green dots, what are they? Can anyone tell? By looking at them, maybe you get an idea. What are we testing?
Are the red the same which is on the
Yes. So red means reject, green means do not reject. And actually we would like to reject because if we reject then the explanatory variables should not be omitted from the model, right? This is very nice, you do it all by yourself, right? Don't show anything. You just have to put cigarettes first, because that's your response variable, and then all your explanatory variables afterwards, and always only in white. First you erase this. Yes, always just the. Yeah, all these explanatory variables. So you have a multiple linear regression with 5 explanatory variables, right? Cigarette price, why? Oh yeah, of course they're in the right order. This is sheet 2 because I did it. So normally they would not be in the right. So should I do the analysis now and then we can talk about it, or? Yeah, I'll wait 5 minutes. Yeah, but this is just because it's ordered. The original data set, this was the observation of the section. Yeah, but when you put them into freestat, it's important that you have the response variable first, right? It says here, what are you testing? You're testing whether these explanatory variables can explain something about the use of cigarettes or the smoking of cigarettes, whatever you say. actually before, did I brag about that? Before, when I converted video, I would have to use the entire night to convert 3 hours of video. Now I can convert 1.5 hours in 10 minutes. So it's really impressive.
Hvad skal du have for en gammel?
I don't know.
Du får den for, hvis du sælger den nu, så får du 2.000 kroner mere i hånden. Men det er ikke one time offer.
Så der er forskellige, der er
3. Vi kan også sige 3.
Altså vi tester, om de har
Ja, vi kan godt sige 5.
forklaret omkring hvad.
Ej, det var
In the testing, if
en lille masse,
the level of secrets can be explained by some of these variables. Before we do the analysis, just let's talk about what would we expect. Would we expect that this variable education, this explanatory variable education, was positively or negatively correlated with cigarettes?
negative correlated.
Yes. Why?
Because education is not, how do you say it?
Well-educated people tend to be more healthy, right, and have a more healthy living.
Yes.
Yes. And for some reason, people with a lower degree of education are not aware that cigarettes are dangerous. Maybe we don't know why. But for some reason, the higher the level of education, the less likely you are to smoke. What about cigarette price and cigarettes? Would they be negatively or positively correlated?
Positive.
Yes. Why?
Because the more expensive the cigarettes is, the fewer people begin to smoke.
Yeah. So they are actually.
Negative instead.
Yeah, because 6, that's the number of cigarettes smoked. So you see a lot of zeros, then you see some heavy smokers like 40 or 60 and some smokers 5 cigarettes a day. I used to smoke and now I chew these chewing gums and sometimes on summer holidays I started smoking this summer. And then because I chew these chewing gums, I need a lot of nicotine. So I smoke 60 cigarettes a day after 2 days if I start smoking. So I'll die in a week or something. Okay, what about race and cigarettes? What would we expect there? Well, actually, it says here it's just this is a binary variable. It's do you remember the name for it?
Dummy.
Yes, a dummy variable. So it's 1 when the respondent is white, and it's 0 if the respondent is non-white. And I don't know, but I would think maybe that that white persons tend to smoke less, but I'm not sure. I would also think that it's very difficult to control for social bias, meaning that if maybe the non-whites are black, then maybe they have a lower level of education and a higher rate of unemployment. And I think that maybe you could find that these persons, respondents, would maybe be more likely to smoke. But this is just an idea. I don't know if it's true. What about age? Any idea? Just say something. It doesn't matter if it's right, just what you think. We are just talking about the data before we have it actually look at it.
I think you're supposed to.
Yeah, so I think you're right, maybe because previously people used to smoke more than they do nowadays. So probably there'll be a lot of elderly people who can't quit smoking. Yeah, the Marlboro people. And what about income? I think maybe income is sort of a proxy for education. So based on just looking at these data, we would think that there would be a negative correlation. The higher the income, the less the cigarettes you smoke, right? So high income, low use of cigarettes. But we're not sure yet. So I'll just do the analysis like you. Did you all do it? Very nice. You are excellent students. It was income and okay, when we have a look at the output, can you see this? Or you also have it on your own computers, of course. Are things the way we expected them to be? We have 807 respondents, so it's a rather large data set, right? And are things as we expected? No? Can you put some words on it? There's maybe a lot of white people with I can see that there's almost only white people in the data set, so maybe it's difficult to really use this explanatory variable because there are so few non-whites in it. What about education? Is this the way we expected it? The education explanatory variable is of course years of schooling, so this would be a very clever person, right? And 6 years, that's not long. Was this this parameter as we expected? Yes. So that was what we expected. High level of education and low use of cigarettes. And what about cigarette price? Is that also the correlation we expected? This is the state price for cigarettes. So a high price for cigarettes means a low use of cigarettes. I think that's what we expected, right? We would expect them to be negatively correlated. High price, low use. And white, that's a bit difficult to say anything. But anyway, if we look over here, we can see that cigarette price is green, white is green, and H is green. What does that mean? Maybe if we just look at the cig price, if I write beta cig price, so the null hypothesis is that beta cig price is equal to 0, and the alternative hypothesis is that beta cig price is different from 0. So, did we reject the null hypothesis or not? Do you remember that? Where do we have to look to find out if we rejected the cig price? This is cig price. Where do we have what? Yeah, yeah, the t value. Should this variable be omitted?
Yes, it should.
Yes, Yes, because the p-value is quite high, so we cannot rule out that actually the intercept is 0, meaning that cigarette price, state price for cigarettes do not have any influence on the level of smoking, right? So this should be omitted. What about this one? Race. The problem with race is that almost none of the respondents are non-white, so maybe that's why we can't say anything significantly here. So this also have to be omitted. Maybe if we look at this one, it's green, but it's the p-value is not that high. So maybe we should just leave it in for the moment and have a look when we redo an analysis and see what happens then. What about up here? What are we testing here? This F value.
Total, we should project the experiment.
Yeah, yeah. If all the explanatory variables could be thrown away, and actually, this is quite high. When we look at each individual variable, we can see that some of them are below 5%. These two are below 5%, education and income, but it actually tells us to throw away the entire model. And if we look up here, what does this tell us? Yeah.
Tells us how much the variance
The
1% of the is explained by the explanatory. 1% of the variance in the data is explained by the explanatory variables.
Yeah, so it's quite low, this explanatory power of the model. So only 1% of the variance in the cigarette use is explained by the explanatory variables, right? So this is not really impressive. I think maybe we take a break and then afterwards we can retry the model with only variables that are significant. Tell me to start the camera. Okay. So you take white and then you take, what was the other one? Yeah, sig price, and delete them, function backspace or delete. And then be careful, you have to copy these. So copy these, not cut, copy. So this is Command C, Control C, and then you can place them where you like. And in our case, we would like to place them there. And then we have to erase the two previous columns now. Now they're copied, right? I'll just wait a minute.
What about education?
Yes, education. What about that? Age. You meant age. Yeah, the reason that I was not too keen on omitting age was that the p-value was not that high. So I would just like to keep it for a minute and see what happens. But apparently it's still not significant. Okay. Can we say anything interesting? Did something interesting happen? If we have a look here at yes? Yeah, now it's significant. Now we can't throw the entire model away, right? We can't omit all explanatory variables simultaneously. So maybe we should just remove age since it's not significant. I thought maybe this would help. So now I highlight age and delete it. And then I copy income. Remember, copy, not cut. And then I delete the old income column. So, still, this is not the most impressive model, right? We explain less than 1% of the variance in cigarettes by education and income. This is not really impressive, right? And we can also see here we are extremely close to the 5% significance level. So we should be very cautious about saying anything based on this model, right? And we can also see here that it's not like that these two explanatory variables are less than 0.0001. They are rather close to the 5% significance level. So if we were testing on a 1% significance level, if alpha was 1% instead of 5%, then we could not use the model.
But in practical, what does the positive and negative correlation mean?
Yes, the positive correlation means if we look at education here, then is this positively or negatively correlated with cigarettes?
Negative.
Yes. Does that make sense?
Yeah, sure, but what
It means correlation means how two variables vary together. So if two variables are heavily positively correlated, it means that when one variable is high, the other one is high. When one variable is low, the other one is low. If they are negatively correlated, then when one variable is high, the other one is low. And when the other variable is low, the other one is high. So in our case, we have education. This is negatively correlated to cigarettes, meaning that when you have many years of schooling, meaning education is high, then you don't smoke so much, cigarettes are low. If you have less years in school, meaning education is low, then cigarettes is high. So this is negatively correlated. I do like this with the hands, and it looks like the correlation coefficient is very high, close to 1, but it's actually not close to 1, right? But this is the idea of correlation. And where can you test the correlation?
you can test it, in the
Correlation and correlation matrix, right?
correlation matrix.
Yes?
What if the correlation is close to 0?
If the correlation is close to 0, like here, then this is not the correlation. If the correlation is close to 0, then the two variables are not really correlated, and then probably the explanatory variable should not be in the model. You can also think of it this way. If you have a simple linear regression with only one explanatory variable, right, and the correlation is close to 0, what would that mean for this value up here? This is the explanatory power, right? So let's just pretend that we have a correlation of 0.01. We have a simple linear regression. We have a simple linear regression, and the correlation is 0.01. What will the R-square value be then? You had a test before, a question. There's some correspondence between R-square value and correlation. No! God damn it! Not the same.
0.02. Isn't it? Have the correlation you'd have to.
Don't you remember the quiz before?
You took the square root.
Yes, try to take the square root.
Right?
Yeah, try to take the square root of this number. This the square root of this number just means 0.01 times 0.01. So this will be 0.001, right? 0.001. So if we have a small correlation close to 0, sorry, then we will have that the explanatory variable, the explanatory power of the model will be very low, right? Did you understand? Okay. So this is not the world's best model, clearly. Compared to the Faner data set, this is not impressive, right? But these data sets are huge and they are so interesting, the parameters in them. Let's have a look at the next one, data set wages. Now you should do a multiple linear regression and the response variable should be wage. Can you do that? So you have to use the dataset wages. These are brand new crisp data sets I found for you. So this is quite interesting. We are so excited. And then maybe you can already before or while you do this, we can talk a little bit about what sort of correlation would you expect, if any, between these variables and the wages. If we have a look at hours, yes, the more hours, the higher wages. And what about IQ?
Probably the same.
Yeah. The higher IQ, probably the higher the wages, right? And knowledge of work, what? That would also be positive, we think. And education, positive, right? And experience, positive. Ja, det kan være, at de er noget med. Må jeg prøve at trykke sæt?
Ja, ja.
Den står han stået væk, måske. Jeg tror, du skal lige... jeg tror bare, du skal lukke med, og så sige ikke don't say. Ja, så prøv lige, om du kan få den til at... Altså, det er jo lidt skrøbeligt, fordi at jeg har jo ikke nok noget beskyttet til.
Det er, så vi
Men
kunne ændre det.
ja, så kan I sidde og pille det i sommerferien, ikke? Very fint. Very fint. Okay, can you say anything regarding the analysis? Or should I wait a little? Yes? These are very interesting, huge data set. You can also have a look at whether people are married and comes from the south and everything. I'm very impressed. Ah, this is much better, right? Mm-hmm. Maybe I should sing a little, because when you watch the video afterwards, then you are not bored while you wait for us to discuss it. Can you get it to work? Maybe if you pick it up like an hour, I think you have the new officer. Okay, can you, oh no, we wait a little or what? How many observations do we have? Yes?
935.
Yes. So this is also a huge data set. How is the explanatory power? We can say that 18% of the variance in wages is explained by these explanatory variables, meaning hours, IQ, knowledge, education, and experience. This is not that bad, actually. Often when people talk about linear regression, we talk about that we would like to have our square value close to 1. But in real life, if you test something like if you go to a bank and you do some analysis regarding stock prices, then you would be quite impressed if you found a new explanatory variable that could even predict 1% of a stock outcome with a high degree of significance. So if an explanatory variable is clearly significant and it does have an effect, even though it's very small, then if you look at something like stock prices, then you can become extremely rich if you can predict one explanatory variable that significantly explains some stock price. So it's not always that we would just like to get close to 1. This is normally if we do some data set that we created just for the convenience. And when you have real life data, often you don't get huge R-square values if you look at something out in the real world. Okay, should we throw the entire model away? No. Can you say why?
The significance level is under 5%.
Yeah, this is actually so low that we can't measure it with these number of digits. So we cannot omit all explanatory variables simultaneously, right? We are testing whether all explanatory variables can be left out simultaneously, meaning that we can throw the entire model away in this test, in the F test. So what it says is that beta hours is equal to beta IQ is equal to beta KK weight is equal to beta education is equal to beta experience is equal to 0, right? So the alternative hypothesis would be not all betas are 0, right? Don't write, if you have an assignment, don't write in the null hypothesis, in the alternative hypothesis, do not write beta H for hours is different from beta IQ is different from, and so forth. This is not the opposite event of all being equal to 0, so do not write that in your alternative hypothesis. Write the same as I wrote in the mind map. Not all betas are equal to 0, right? Do you understand that? Okay, so we found out that we cannot omit all explanatory variables. Can we omit any? Should we omit any?
We could omit hours.
Yes, hours apparently has a p-value at 7.15%. So it's not really, it depends, if you had a 10% significance level, you would not omit it. I think maybe we could just leave it since it's 7%, right? What about the correlations? Are they the way we expected?
Yes, it is.
No, hours for some strange reason, average weekly hours, the more you work, the less you earn. So that's strange. Maybe, I don't know, this is an American data set. Maybe it's something like if you flip hamburgers at McDonald's, then you make so little money, and maybe you have to work really hard in order to earn a living. It's not like in Denmark that you have a reasonable minimum wage. So we are very fortunate here. Okay, what about, can we say something, in regards to which, if you look at these numbers, these beta estimates, can we then say that one explanatory variable explains more of the variation in the model than another one? It's a trick question. Actually, our problem is that if we look at this, I would like to say, oh, years of education really means something in regards to the wages, right? But the problem is that it depends on the scale we use to measure. So if instead of years of education, we used minutes of education, then this would change drastically. This would be much smaller. Do you understand that? So, for instance, if we measured IQ score in another scale and average weekly hours in another scale, then these beta estimates would change. They change according to the scale we use. So we can't look at these numbers and say one explanatory variable affects the model more, affects the response variable more. That's not possible to say based on these. If we would like to say something about that, we should use some standardized betas, but that's not part of our what we have to learn here. Okay. So we should actually keep all our variables in the model. Can you maybe say something about which sort of person who can you maybe calculate if a person has works 40 hours a week and has an IQ of 100 and has knowledge of work at 1 and 10 years of education? Oh, I say a lot here. I'll have to write it down so we remember it. So if a person works 40 hours per week and has an IQ of 100 and knowledge of work 1 and years of education, 10 years of education, and has 5 years of work experience, can you then calculate what his expected wages should be according to our model? Is that possible? Do you know what you should do then? You should do the same as when we looked at summer houses, where we actually, you just did it before, when you said 544 plus 10 times, and then we had, what was the variable in the summer houses before? What? 49, what was that? I forgot that.
Square meters.
Yeah, square meters, yeah. So we took the square meters, that was the explanatory variable, and multiplied by 10 and added to the 544. Now you should take the intercept minus 416 and add 40 times minus this number and so forth. Do exactly the same, it's just more complicated. So actually you use the model to predict the wages of a person. So based on this model, this is why we do the model, so we can predict something, right? So actually based on the model, we can predict what we would expect the wages to be for some person. So you already did it, but it was just more simple before. Actually, if you find an empty cell like this, you can just do the calculation there. Then you can just say equal to, and then this number plus, and so forth. Do you understand? So you don't have to write down all the numbers. Isn't it quite fun to do this type of analysis compared to normal distributions? You can use this for something, I mean. Actually, multiple linear regression is like the Nicholas Bentner of statistics.
Not very good.
Oh, okay, then some other person. The Messi of statistics.
Hvis det er ligesom Messi, så er det
Oh, that class over there looks much more interesting there. Drawing airplanes on the blackboard. It's like an electronic. I think so, but I'm not sure. What number do you have? I can write it down. What is the number? 397. Actually, of course, these wages are in dollars, but it's not that impressive, right? What is the maximal wage? There's one person who makes $3,000. Maybe it's $10. Yeah, of course the data is a little bit old, but still, maybe the dollar was very strong. No, maybe it's low wage respondents. Okay, so what was the estimated wages? Did you all get 397? Okay, so we go on a little bit. It's I was just talking about it's a little bit low. It's per month, but that's not much money. So of course the data set is a little bit old, but still it must be in dollars, of course. But still, it doesn't sound like much. Okay, so we take the next question. There you have to use the sleep data set. And just two explanatory variables. Oh yeah, sleep. So age and good health. So this is a dummy variable one if you think you have good or excellent health. and the response variable sleep, that's just minutes of sleep per night, per week, sorry, I think. So this is also a huge data set. So sleep, that's minutes of sleep per night. Per week, sorry, per week. Age and good health. While we wait, maybe someone can explain to me how can we calculate this number up here based on what we have down here in sums of squares. Do you remember that from the first time we looked at linear regression with the red boxes and the blue boxes, or the red boxes and the purple boxes? Sums of squares error and sums of squares total. So the way we calculate this is always to take 1 minus sums of squares error. SSE stands for error. Sums of squares total. SST stands for sums of squares total. That will give us the R square value. So you can say 1 minus this number divided by this number, and then you get the R square value. Is the R square value high or low? Yeah, it's low. So there must be many other factors aside from this, from age and good health that explains the sleeping patterns, or rather the minutes slept per week, right? Because only about 2% of the variation in sleep can be explained by these variables. So it's not that impressive. But is it significant? Should they be omitted from the model? Do they explain anything regarding sleep? Yes, they do, right? Because both are significantly different from 0, meaning that none can be omitted from the model, right? They are not really impressive, right? They are not like below 0.0001. What does the intercept mean? What does the intercept tell us? Yes?
That in average, everybody gets 3,200.
Don't say average. Remember before when we talked about houses, we talked about a house that was 0 square meters. So which type of person, according to our model, sleeps 3,200?
0.
Yeah, a newborn.
Yeah.
With what sort of health?
Good health.
No.
Good.
With a
Bad health.
yeah, with a 0 in the health, right? So a newborn with not good health does sleep 3,260 something minutes per week, right? Did you understand that, all of you? Yeah, very good. I think you are so good, so maybe we could take that quiz now. Yeah. Yeah, sums of squares error. Sums of squares error. So SSE, that means error here. And then you can see it says sums of squares here, right? And why did it say sums of squares? Because you take a lot of squares and then you sum them together, right? Jo, jeg skal nok lade være at gøre noget. Det er bare for at vise, hvad det er. Nej. Så er det altså
Jeg kommer kvart over og fint med. Jeg elsker det. Man kan godt lide det. Nej, det første jeg siger, når jeg tager det. Men det er ikke noget, jeg får. Man kan jo sige, det er noget stjæl.
nej.
Nej. Køber jeg madbilletter? Nej.
Og den fortæller os, hvordan sammenrejsen er i de to varianter. Men nu skal jeg lige passe på, hvad det er, fordi hvis vi finder på er square,
Jeg havde høj moral.
så er det jo ikke korrelation.
Jeg skulle Du skal bare slet ikke snakke om det der med det her. Du skal slet ikke lave mig.
Og Jakob betaler forretningen sin måde. Daniel, nu hvor du er ny, så har jeg en meget speciel opgave. Der er noget svind i virksomheden.
Du ved, hvor mange der betaler på madår.
Det er faktisk på madår, vi skal have.
Så siger jeg møder dig sagt, det er det synes jeg også. Stadig. Det koster over det.
Ja,
Jeg kan gå på spise, eller jeg vil I går, hvor jeg var med 3 timer. Og jeg nåede at pause nu, ikke?
Jo, det har det bare havde vi normalt 2 år.
Ja, det er helt. Sindssygt. Det er en god måde foran os. Ja, det er en god måde.
Det var det, som hørte I lige fra rundt.
Tag så meget af det.
Okay, men det svarer til en ny
Du bare hostler, mand.
fordi jeg ager med
Skal jeg bruge pause for at spise? Nej, selvfølgelig skal jeg ikke. Det skal jeg da betale. Skal jeg da betale for noget? Nej, selvfølgelig skal jeg ikke.
Venter de i aften, den er med mig. Betaler 400 kroner om måneden.
Du er ikke har han tid. Det er rigtigt, du er ikke har han tid.
Det var jo bedst at sige halv pris, så kan jeg godt lægge det ud til.
Ja, man skal sige ja, det var med.
Og det skal man ikke. Så har jeg også gået med, jeg skal ikke komme i men altså, hvis jeg skulle spise for 400 kroner der på måneden, så er det så lidt, så skulle jeg, men det er mega blødt, men vi vil jo ikke stoppe med at spise, det skal være med kæmpe med mig. Men nu er jeg kørt så langt, nu er jeg sådan set, hvis ikke man får det gang, så er det jeg vil gerne melde mig til madordningen.
Kan I huske det sommerhuset før, så blev vi enige om et sommerhus, der havde et større på 0 kvadratmeter.
Jeg vil gerne snakke med dig. Jeg er blevet
det er det, vi siger.
Hvis vi siger noget om det tale, har de har en bedste hold.
Jeg skal ikke sige noget negativt.
Ja, det er en kommende. Så 1 er sportshelbred, og 0 er
Vi skal bare sende ham den engelske, når det altid kommer.
Men du kan også være foran 3-0, og de 89 minutter, så har det andet hold en chance. Så springer de langt. Det kunne have sat sig tilbage i kampen, men det ved vi jo ikke nu.
Det er alligevel lidt skægt, synes jeg ikke?
Thomas?
Ja.
Du mangler lidt stikko.
Ja, men så er den gået i gang. Nu har I ikke fastet ind. Nej, den skal lige. Okay, this is the page.
Hvem hedder Sigøjnermænd? Ja, det er sjovt.
Hvad skal det være? Nej. Skal vi have med, at vi bliver lagt sammen, så bliver vi lagt sammen og holdt scenen?
Who's not in yet?
Den kommer lige på.
But it says French.
My name is not Oscar.
What's your name?
Kæft, 20 Sigøjnermænd.
Der er fisherman.
Okay, when you're in, we start, right?
Ja, ingen kommer der ind. Det er overhovedet ikke dansk.
Sidder du lidt af?
Can I start?
Yes.
Okay, I start now.
Det er fordi, du må med over det.
Tror du det? Ja.
So sorry.
Ah, very good. So, why did you answer it was multiple?
Jeg synes, der har en min. Nej, kæft, hvor det godt.
No, this is not the one.
Det sker bare. Nej. Jo, mamma skal nok komme igen.
No. Was it this one? Okay, why is this linear regression multiple? Yes? Yeah, explanatory variables, yes. Education, years of schooling, income, annual in US dollars. Perfect. So we take the next question. Ludwig.
Yes.
You have to know that in advance. After, we'll talk about it afterwards. Okay, can the explanatory variable education be omitted? What does omitted mean? I said it many times, you didn't understand what I said before. What is he talking about? Yeah, omitted means that, not reject the null hypothesis. Omitted, if you omit something, you take it out. Yeah. Or you don't include it in the analysis. So when should we omit? When should we omit?
Over 5%.
Yes, because when we cannot reject the null hypothesis, then beta could be 0. So we omit the explanatory variable. Yes?
Den her var der under 5%.
I hope you're not right. Then I made a mistake. Let's have a look. Education. Oh my God. So this is below 5%, so we cannot omit it. I'm sorry, it should be. I'll just have to have a look here. Yeah. Okay, your answer was right, and I made a mistake in the quiz. Sorry. Do you all understand I made a mistake? If it was like 6%, 6% here, then it should be omitted, right? But this is below 5%, so you were right. Very good.
Så ikke statistikken omkring hvem der vinder helt vildt.
Det er lige meget sådan.
Ja.
Bare fordi du svarede ja, eller
Prøv at se. Hold kæft, mand.
Very good. You are excellent students. I'm very impressed.
Fuck, kan du gå tilbage? Hvorfor kan du gå tilbage? Ordet fanger lidt.
Very good. You really got the hang of it. Why do rich people smoke more according to the model? Yes? Yes, because this parameter estimate for beta is positive, then we know that according to our model, rich people smoke more. Of course, we can discuss that this is very close to zero, but if you have to answer something, you must say yes, right? You're so good at this. So, do you all understand why this is right? Okay, let's have a look. The question was, is one null hypothesis tested that beta income is equal to zero? Where is that tested? Why did you say yes? What are we testing here? What are we testing here? Yes? Oh. You're off the hook. Okay. The rest of you, why is this null hypothesis tested? Where is it tested? What are we testing here? We are testing, yeah? Yeah, we are testing that beta education is equal to zero is our null hypothesis. Our alternative hypothesis here is beta education is different from zero. Down here, we are testing exactly this in the null hypothesis. Beta income equal to zero, and the alternative hypothesis is beta income is different from zero, right? Do you understand that? We always do the same test if the slope is zero or if the slope is different from zero, right? So actually what we are asking here, is the slope different from zero? Yes. Is the slope different from zero? Yes. Why is it different from zero? Because the p-value is below our significance level, right? So we are testing here, is the slope different, beta, the slope, is it different from zero? And we say yes. This means we cannot omit this explanatory variable from the model. We cannot omit this explanatory variable from the model. Okay, we try the next one. The cable thief. Why don't you write your names in English?
Hvem svarer så hurtigt?
The p-value for the test that all explanatory variables can be omitted is 0.0428. So where should I look for the test that all the explanatory variables could be omitted? Yes? Yeah, prop F. So this is the p-value, and the test is, can all the explanatory variables, that is beta education and beta income, be omitted? Is beta education equal to beta income equal to 0? That's what we are testing in the null hypothesis for the F test. Can all the explanatory variables be omitted simultaneously? Meaning, can we throw the entire model away? And then, if we say no, we cannot, then we go down and check here each explanatory variable. Should this be omitted, this be omitted, this be omitted? Do you understand? The p-value for the test that all the explanatory the p-value for the test that all the explanatory variables can be omitted is yes, but if this is I just asked what the value was. I didn't say anything about if it was omitted, so I only asked, is the value this? Yeah.
Okay.
Don't ask me that, then I get afraid I made another mistake. Okay. Yes, I made it last night. You can see here that I made the last questions just before midnight, so I was very busy. Okay. So, yeah, next one. So it didn't go so. Why did you answer no, by the way?
I looked at the wrong one.
Okay. So now we know where it is. Very good. Actually, I'm not really proud of this way to formulate the question, because in some literature you call the intercept beta 0, so then you also call it a beta. I have to rephrase that, but you got the meaning. Very good. So, question number 10. Oh. So what does this residual QQ plot tells us? Do you remember we discussed this previously? We have some assumptions when we look at linear regression. One is that the residuals, meaning the errors, the differences between what we observe and what our model predicts, these errors or residuals should be normally distributed, meaning that we would like these to be normally distributed. When are they normally distributed? They are normally distributed when they are close to the line. There's a big problem here because you can see that we go quite far away from the QQ plot line here. And often it's not a problem that you have some outlier, something like this and this in the end, but you must never have a break or a great variance in here in the middle. It's of course difficult to say exactly when you say one thing or the other, but this doesn't look good. Borskov, who's that? Ah, very good. Only one wrong. Okay, let's just, we can just, if we're quick, we can just have the first one again. Not the one from today, but we take the one with 15 questions. I'm not sure you had this before. No. Then we try this. Yes, you have to restart it. Just open a new browser window and shut the other one down. You're quite good at this, I think. Do you understand a lot about linear regression already? Monday when you have the test, we haven't had many hours regarding linear regression, and the test is quite large, so you'll have problems solving all the questions, right? But I hope you do okay. Of course, I would be nice to you, especially regarding linear regression. Because we didn't have much time. There was one, was it question 3 or something that I made a mistake? Did you make the wrong one you had? Was that in the question where I made a mistake? No. Are you all in, or should I wait a little? All in.
All in.
Oh, we have to wait for you. Yeah. So I start now. Oh, that's strange.
I
Don't you remember the binomial distribution? If x is binomially distributed, then you write it as a b for binomial distribution, and the parameters are the total number of experiments, and then we have the probability p, right? The success, the probability for success, right? You remembered something from the first quiz, but you have to look at which, in the first one it said something like the mean is greater than the median. So if the mean actually is smaller than the median, then the distribution will look something like this, skewed to the left, right? Do you all understand? The median is outlier stable, so the median is somewhere here, and then we have the mean over here somewhere. So this means that the distribution will be skewed to the left.
Okay, good.
Bobble. Ah, very good. Leptokurtic, it leaves, right? Yeah, so kurtosis is positive. So one continuous sample means that we test the mean mu, right? Mu is the mean. So then we are told that the mean is greater than, how does greater than look? It looks like this. And then we say mu is greater than 25. In which hypothesis should this go? Yes. This should go in the alternative hypothesis. So now we know what the null hypothesis is, right? It's mu less than or equal to 25. Do you all agree? So it was this one that was right. Did you all understand this? Perfect. Ah, that's better. So it says here the mean greater than or equal to, greater than or equal to. Greater than or equal to looks like this, right? So it must be mu greater than or equal to 25. Is this the null or the alternative hypothesis? Yeah, this is the null hypothesis. So the alternative hypothesis must be mu is less than 25. So I think maybe these questions with hypotheses, you should be careful and just take your time to answer them correctly. Maybe just quickly draw something. Blomst, who's that? Oh, very good. Bobble, who's that? Ah, very good. Yeah, this is a hard one. So let's have a look. What does no less mean? This is difficult. No less.
Can be 0.7.
Yes, it can. Yeah. And no less means that it can also be what? Yeah. So it can be above and it can also be equal to. So it's something like this, right? Do you agree?
Yes.
Yeah.
So this is proportions. Should I then put mu greater than or equal to something? Or what should I write now? Should I write mu here? Why?
It's proportional.
Yeah, it's proportions. Thank you. So P is greater than or equal to 0.7. Is this the null on the alternative hypothesis? Who's an alternative? Never put an equal sign in the alternative hypothesis. Okay, so then we know that the alternative hypothesis is this. Okay. Okay, we try the next one. Ah, very good. So you all understand, of course, this was P and not mu, and not equal to will always be the alternative hypothesis, right? Because the equal sign must always go in the null hypothesis. Bellis, who's that? Ah, the dream team. You're 1, 2, and 3? that's funny. How many percent is this?
44.
Yeah, this is 44%, right? And what is the significance level? If
5.
nothing else is stated, yes. So this is above the significance level. So we cannot reject the null hypothesis. Do you agree? Yeah. Do you all understand? If this p-value here was 0.04432, then we would reject the null hypothesis. If it is above, if the p-value is above the significance level, then we cannot reject the null hypothesis. Small p-values, small p-values, we did this all the course.
Yeah.
Small p-values mean that we reject the null hypothesis. Why is that? Because what we are testing are the tails. So small p-values means we have small tails.
Yeah.
These are the tail areas. Meaning, what is the probability under the null hypothesis to get a result more extreme than these values? And that will be very small probability. So
44 now.
yeah, 44%. Do you understand?
It's much easier to get a large amount.
Yes, it's you have some measurement, and it's very difficult to reject this null hypothesis because there's a 44% chance that if you read the test with exact same sample size, that you would have a more extreme result, more different from mu than this result. Yeah, maybe it's a bit difficult, but just remember, small p-values are critical to the null hypothesis. Small p-values are critical to the null hypothesis. They mean reject. Small p-values are critical. Your party?
Yes.
Two continuous samples of house prices with equal variances. We see here equal variances. Then we know that it must be pooled and not unpooled. But why is it not paired? Paired, that was the treatment. Yeah, exactly. Okay, I'll hurry up because maybe the time is. Okay, should I hurry up a bit? You would like to finish it, I expect, right?
Yes.
Yeah. Oh, so this was mu1 and mu2. There was no p, so it can't be anything with proportions, right? So these go out, and it was not test of one mean, it was mu1 and mu2. So it must be a test of two means. Do you all understand?
Yeah.
P for proportions, mu for mean. Base. Yeah, this is critical. A test statistic is exactly the opposite value than a p-value. So large test statistics means that we reject the null hypothesis. Oh yeah, yes. The p-value was below 5%, right? So we reject the null hypothesis. Well, the kurtosis was minus 1.1, I think, so it must be very flat, meaning that negative kurtosis, then it's plateau-curvature. And then the skewness was just around 0, so it would be symmetric line. Yeah, the p-value was above 5%, and so we could not reject the null hypothesis, and the null hypothesis said p1 was equal to p2, meaning the proportions are the same, right? So let's just have a look at the scoreboard. Bellis, Bobble, and Blomst. Oh, all the girls. Very good. Okay, then have a nice weekend. Det var hyggeligt. Ja, men er det ikke meget godt, fordi I kommer alligevel til at huske på nogle ting? Nej, de er sådan mere fredelige, men altså, der er mange, der er for meget svært at sige, men vi gør det bare. Nej, det er sådan helt almindeligt gammeldags med spørgsmål, ligesom det bliver lavet til exercise. Ja, og sådan lidt forskelligt.
Multiple choice eller hvad?
Nej, det gør det ikke.
Nej. Vi skal vel ikke op i det? Jeg skal bare